Welcome back to another video. Last Tuesday I asked you guys if I should continue to do the YouTube Tuesday videos. And I had a response from one of you guys that made things quite clear. It says, I think that YouTube Tuesdays should continue due to people like me that own their own small business shops that need to find the texts that either give you different ideas, techniques, or what have you to better understand and also apply more services to customers. And I totally agree. And something I realized is that maybe I won't focus specifically on finding new channels, although I know inevitably I will, but maybe I should just highlight good videos in general. So that's what I'm going to do. We will definitely be highlighting the channel, but if I find a channel with several videos throughout the year, I will definitely cover them. So if you find a video that you think should be covered, link it in the comments down below, and I'll definitely check it out. Now today we're going to be taking a look at another VCC Board Repairs video. It's titled, My Technique for iPhone CPU Reball. This iPhone 15 Pro was water damaged really bad. That being said, let's get into the video.
This is an iPhone 15 Pro CPU and it holds the keys to the customer's data. So this iPhone 15 Pro came in for water damage data recovery, and take a look at how bad of a condition it's in. The motherboard was even in worse condition and somebody else had actually already worked on it and failed. This is an iPhone 15 Pro CPU and it holds the keys to the customer's data. So this iPhone 15 Pro came in for water damage data recovery, and take a look at how bad of a condition it's in. The motherboard was even in worse condition and somebody else had actually already worked on it and failed. It came to my shop and my job was to fix the board enough to turn it on and get the customer's data, but that was unsuccessful. So what I found was some extreme water damage in this part of the motherboard that ate away a bunch of the components. Plus there's a lot of corrosion in other spots on this motherboard. So we went to the last resort option, which is called a CPU swap or a CPU transplant. This is where we remove the CPU, the NAND, and an EEPROM chip from on the customer's motherboard, and then we install it onto a different motherboard that's fully working. So this is one I've used for another CPU swap, and I know it's good, and I've already prepped it for this CPU transplant job. But in today's video, I'm going to show you guys the step-by-step process to reball a CPU. Now this process is very delicate, so do not try this at home if you don't know what you're doing. I've actually already reballed the NAND because that one's a lot easier. The CPU is much more difficult. If you damage the CPU, there's no way to get data because these two chips are essentially paired together. So basically these two chips talk to each other in order to decrypt the data that's inside so we can get access to it. And the only way to do that is to get the phone to turn on. So we're going to install these to the board, get the phone to turn on, put in the customer's PIN code, and then we can unlock the phone and get all the pictures and videos out of it. So if you guys have a water damaged phone that is destroyed and you need your data out of it, reach out to me through my website. You will see a link right there at the bottom of the video. I'll also link it in the video description. We do offer mailing service for anyone in the US. So first, let's start off by inspecting the CPU. I've already done the hard part of removing it from the board. That is probably the riskiest part. The next one is cleaning the underfill. There's basically a bunch of black glue that's stuck on it. So I've gone through that process of cleaning it up as well. And overall, the CPU is in really good shape. No rip pads. There's like a little bit of underfill here, but that's minimal. We can leave that as is. But overall, this looks good for the next step, which is the actual reball. This is something a lot of people struggle with, and this is basically what we're going to use. So this is a stencil. This is what allows us to reball the chip by adding paste over the CPU, over the stencil, and it basically leaves behind just enough paste for each ball on there. So when we heat it with hot air, it forms a ball around it, and then we have a reball. But the tricky part is because the CPU is so large, what happens is the heat causes this to bend, and then you'll have a messed up reball. So anyone who's tried reballing even on the smaller chips knows what that's like. So there is a technique to do it properly and do it successfully. So when you do a chip like this, like a really small one, what happens is if it does bend, from the heat, it'll warp. It's not enough to really affect the reball. But once you start getting to the bigger chips, then you'll see how much difficult it is. So one of the secrets to reballing is having a clean cloth or like a paper towel. This cloth right here is very soft. It is kind of very paper towel-like. It's not like this one. So you can see I'm holding the edge and it's not folding. This is very thick, fibrous paper towel. Versus this one, this is like a cloth. It doesn't have any form. If you try reballing on one of these, it will melt. But this one is way more durable. I will try to see if I could find this exact one online, although I haven't had luck. So next best option is a paper towel, a really thick one, and then you fold it a few times so that you get a good thick surface to basically work on. So we're gonna put the chip on top of here, and then the stencil on top of that. And then what happens is when you're pressing down to reball, that's gonna essentially cause the chip to sink into the paper towel, and that will form a much better surface for the reball. So as you're working on it and pressing down, it kind of concaves and makes the stencil a lot more flat. So that's kind of one of the tricks to preventing the warping.
All right, so as you can see, he's really clear on what he's trying to do, and he's actually, so far I have really no negative critiques. Everything that he said I really like. Now, one thing that I like to do personally when I'm rebuilding a CPU is on top of doing this, which I use the paper towel method, but I like to fold over the ends so that it leaves a gap that's big enough for the CPU to fit or whatever big IC I'm doing. And that almost creates the stencil to be somewhat concave so that if it even wants to warp, it's only going to flatten out even more. So having those layers of the paper towel creates kind of a sponge effect where it compresses in and it gives it that flatness. But folding over the sides, and you'll have to play around with this, see if you can find something that you like. But I like that. I fold it over so that it kind of meets up with the edge of the CPU. And almost creates a valley where the stencil doesn't necessarily, it's pretty much flat, but it does have a slight almost concave bend like that. So it works for me that way. One thing that you'll notice is that it almost looked like his CPU was already reballed. It's probably just the way that it was when it came off, and that he's cleaned off the underfill without wicking, without removing the solder. And there's a couple reasons that I would see him doing that for. One is that wicking is kind of like, it's the equivalent of taking almost sandpaper to some surfaces. The copper braided mesh wire that you do drag across surfaces can abrade away the surface of the CPU, causing some of those traces to be exposed, causing bridging, causing shorting, potentially causing issues. So although in the past I've almost always wicked everything to put new fresh solder, the solder that I like, I've realized that there's a lot of reasons. And let's see, I can't remember exactly what he said as to what he gets in, or as to his reasoning behind it, but if there is something that he doesn't say that I want to add, we'll get there. So let's continue watching.
So take a look at the pattern under here. There's these chips here that are under the CPU. I think they're like capacitors. I don't know.
Yep.
Honestly, doesn't really matter. Fact is that they're here. Look at the pattern. And then we're dealing with the A17 CPU, which is no longer labeled. Previously, older CPUs, it says the CPU number on there. This one doesn't, which if you look at the stencil, it matches that A17. And then let's do this. Let's rotate the chip to match the stencil. Right, so you see the cutouts. You want to match those with the chip. And then let's match the corner like that. So one thing about this stencil is that it's 2D, meaning it's just a flat metal stencil. There's no
3D. Kind of 2D.
Semi 3D, because it has the little cutouts for the little squares. So that does help a little bit, but not that much. So you'll see. So one of the biggest problems, another big problem people have is they have this down like this. You go to apply paste, and then it starts shifting around, and then it gets misaligned. So that is something also that's difficult with these stencils. This is a regular stencil. I'm not using a special jig because they didn't have any available. They probably have some available now, which kind of makes it a little bit easier, like a magnetic setup that will make it a lot easier to reball. But even then, that one still warps. So what we do is first we lay the stencil down, and then I use 2 fingers on top and bottom to like hold the stencil in place, hold the chip in place. This is the reballing paste I use for CPUs. I know a lot of people like to use lower temp, but I prefer this one. So you notice it's 183 Celsius melting point. It's basically 6337 alloy. That's probably the best solder type for this type of work. And it also has a nice amount of flux in there. So this is the best one I found so far. It's kind of hard to see inside, but there's some paste in there. So the middle center is like the wettest part, and then the edges is the driest. So what we got to do is scoop out, I would say, a big amount like this, right? So kind of like a pea size or like a bean. Actually, I should have done this before. And then on the same clean cloth, but actually fold it open, what I'll do is try to dry it out. The goal is to not have it be too wet, otherwise it's gonna mess up your reball.
You can already see how dry his solder paste is. It's not even sticking really to the cloth, to the paper towel. If you have too much flux in your solder paste, it can cause a lot of issues where the solder will want to basically run all over the stencil. It'll want to jump out of the stencil. You do still need flux. You still need to have some flux. But his solder paste looks dry enough that he probably doesn't need to do any drying at this point. If you've got really new solder paste, it's going to have a lot of flux. And what I like to do is I like to smear it into the cloth. I like to drag it and really smear it just a really fine layer. And then I go back and I scrape it back up. That way I give basically all of it a chance to let the flux leach out of it into the cloth. In this case, it's just he's dabbing the exterior, not the interior of the clump that he has. So whatever flux is inside the clump that he's dabbing onto the cloth isn't having any of the flux leave. This is already really dry, so he probably doesn't need to do this step. So when he goes to apply it, I'm sure we're going to see that it's very almost like wet sand. What wet sand looks like when you kind of smear it, where it kind of clumps up, stays somewhat clumpy, gritty as he goes through it, instead of being like a smooth paste, like a peanut butter getting smeared across something. It's going to be more like chunky peanut butter versus the regular butter just smearing it. So probably doesn't need to dry out any more than it is. And you can tell that he's definitely used this solder paste a lot because he's down at the bottom of it. 183 is definitely a good range for data recovery. If you're going for longevity of the device or you're trying to repair a device, CPU, a NAND, a PMIC, one of the bigger chips, you probably should go with a minimum 183. I would even go up to 217 for a CPU. For data recovery is totally fine. You could go down to like a 158 or 150 for data recovery, but it's really easy to work with. The lower you go in temperature, the easier it is, but there's some properties to the metal that make them less conductive, and it won't perform the best as far as passing data through the actual solder itself. So you want to maintain those properties. For such a chip that gets hot, the CPU gets hot, then this is a component that does need, that will warm up because of the amount of thinking power that's going through it, the amount of electricity that's passing through it. And so you do need to have a solder that can withstand the strain of the heating and cooling that happens repeatedly on a motherboard. So 183 is kind of on the lower end of the temperature that I'd recommend, but it's totally acceptable for a short-term data recovery where you're not looking to use this phone for an extended period of time running heavy programs like a game or something like that. So let's keep watching.
So I just kind of go like this. Now this paste is kind of old too, so even though it looks wet inside, it is a little dry already. So let me scoop up a little more, try to get a little bit more moisture. The moisture is basically the flux, so just keep that in mind. If you have a brand new bottle of this, what you're gonna find is it's gonna be very runny. So I just never close this. I just leave this open because I do want it drier than what it's like new. Then I have a special spatula tool like this. It is non-magnetic for another reason, but what I like is how bendy it is. It is like the right amount of tension for this type of work. So once I dry out the paste and I see it's no longer leaving residue on my towel, then it's pretty good. Then I'll scrape it off and essentially transfer it onto this one. The goal is to end up with a little pile like this. All right, so now we're back on the stencil over the CPU. I have my pile of paste on here. You can see it's a pretty good amount, right? That's the amount I have. And then while my two fingers are holding the top and bottom, and also notice the orientation. I have the long ways left and right. This allows me to apply the paste much easier and less warping. So like I said, one of the biggest issues is the stencil will warp, it'll curve, and then the paste underneath will move around. So the goal right now is just kind of...
So as you can see, if you look really carefully at the solder paste, it's very dry. And what happens if you have it too dry is that as you go over it, the solder will go down into the little stencil, but then it'll almost like kind of pull back out a little bit. So what you get if you go too dry, he'll probably be okay with this, but if he goes too dry, you will definitely have an uneven solder array across that stencil. When you look at the actual individual solder balls, they're not going to be the same size. Now, if it's too wet, if it's got too much flux, then you create a whole bunch of issues with the flux kind of boiling and forcing the solder to kind of go wherever it wants to. It can go under the stencil. It can boil out of the top of the stencil and jump into the next one. So you have to find that balance, which only really comes with practice and time, of finding the right consistency of solder paste so that you get the correct amount of solder deposited in the stencil. And there's ways to correct it if the first time it doesn't have the right amount. You can go back in and add additional, scrape away the tops of them, add more. But so far, I like what he's explaining. I like that he left the solder on the CPU. That kind of prevents the stencil from sliding around too much. It helps kind of align it. He left all of the capacitors on there. Sometimes they just come off when you're pulling the CPU off the board. If they come off, just leave them off. It'll work for data recovery without them. So don't fuss too much if those little squares, those rectangular capacitors, if they fly off. But let's just see where he goes from here.
Kind of push down and slide and spread this paste out. And then I flip over my tool and then I go into a scraping mode. Another thing is I don't wick the CPU flat, because that is very risky and is not required. As you'll see here, I'm able to apply the paste and I'm able to reball all this without having to wick it. Now, if you want to see a video from beginning to end of this process, I do have an iPhone 12 where I do a CPU swap, and then also have another video where I show how to prep a donor board. So I have separate videos for that. I will link them down below in case you want to see those. Now that we've kind of scraped it flat, I use a clean cloth to wipe it down. Now this is the actual cloth that I'm able to wrap around my finger. Just press it down. Now we gotta use some curved tweezers. These are really large tweezers that allow me to basically hold the stencil down from the top and bottom.
Now I have a pair of tweezers. Let me see if I can find them real quick that work really, really well for this circumstance. All right, and here they are. As you can see, they have what I would consider the perfect angle for putting pressure on a flat surface. On top of that, they've got two nice flat. You can tell that the ones that he has are slightly curved, which will give you this rocking effect. These ones are fairly large. I mean, they don't go the full distance of the CPU, but they cover typically more than half, if not about 3/4 of the CPU. And it allows you to be far enough away from the heat gun that you're not burning the tips of your fingers, which is another issue. But it allows for that nice even pressure so that you get the stencil to not warp as much. And there's a couple techniques that you should use when working with stencils, because all metal will expand when you heat it up. And if it expands more in one area than in another, it will warp. And so if you heat up the entire stencil, it'll have less warpage when the time actually comes to apply all of the heat into the solder paste so that it melts. Let's see what he has to say about going through that technique, because I'm sure he'll explain it like he has everything else very clearly.
And then I'm going to switch pressure. So I'm going to let go of my fingers as I now add new pressure from my right hand from the tweezers. So now I've let go of this, and now the tweezers are the one holding the stencil down. All right, so now this is what the solder paste should look like inside the stencil holes. See that? It's very dry looking. It's not super shiny or wet. And now we're going to use 330 and 25% air, 330 Celsius and 25% air on my add-in hot air station. I will link to this hot air station down below as well as the stencil and the paste and everything you see in this video. If there's anything I left out, let me know in the comments. So right now what we're doing is heating it from very far away. I'm just trying to heat the stencil. So if you can see, my hot air wand is just going everywhere. The goal is you don't want to go straight in to try to melt the paste. First, you want to preheat the whole area. So let's go in big wide circles for maybe 30 seconds or so. And let me see if I can get a better angle on this. All right, so I'm going to zoom in so you guys can see kind of what happens to the solder balls once they start melting. All right, so since I preheated it for a good amount of time already, I'm now going to start moving in a little closer and kind of focusing on one corner. So I'm doing smaller little circles on this upper left corner, and I'm just paying attention to the paste. Take a look at the paste. See that? See that? The solder balls are forming, and you want to do this very slow. There's no rush. The faster you go, the more likely you are to mess up. So you can see there's a partial, like half is solder balls, half is still paste. And essentially just kind of keep going these circles and moving in closer to the chip and then moving to the right. So the goal is to kind of form them all in a slow formation. So I kind of heat the top, and then I heat the bottom, and then heat the top, and then the bottom. Now, this is hard to do with just two hands and record.
Yeah, kudos to Jesse for doing this. It is hard to record a video and try to do a repair at the same time, because he's obviously doing this for somebody, and in filming it, he has the potential to, just because he's trying to get a specific shot, he has the potential to have to reball it one more time because something gets messed up because he's trying to capture what he's trying to explain under camera. So he definitely deserves credit for that. And you do too if you've stuck through this far in the video. If you're finding what he and I are saying useful, like the video and comment down below your favorite bit of information that's been given. Or if you have any questions, leave them there as well. Let's keep going.
Now, a common thing that will happen here is you'll be doing this, and then you'll see some balls will just squeeze out really large, and then or you'll see a solder ball pop out and jump into the next spot. That basically means the solder paste was too wet, so the flux started bubbling, and it bounced to the next. It causes the paste to bounce out, right? So right now the solder balls are still molten and they've now dried out or solidified, but we're not done yet. So take a look at this. Look, I see one right here that's kind of messed up, so that needs to be addressed. But the rest look pretty good. And one way to be sure that you have even solder balls, oh look, there's some gunk right here, is to get your blade, like a X-Acto blade, and just start shaving the top layer. This is kind of a test in a way. You should, if all the solder balls are even, what you should expect is that all solder balls will have a piece of it shaved off the top. But as you can see, it's very uneven looking. It's very unlooking how these are being shaved down.
So I'm going to put the blame on the solder paste being a little too dry in this case. There's a fine line between it being too dry and the perfect dryness. And so I think that in this case, it was just barely past where it needed to be in order to have deposited the perfect amount in the stencil so that none of it got pulled back up when he was spreading it or when he went back over to kind of suck up to clean off the surface with the cloth with his finger. I actually find that I like to leave the solder paste with almost a little bit more flux at the beginning that I would like, and when I go back over with a cloth, that tends to absorb because of the heat of my finger, the friction that's caused moving it around. It kind of activates the flux a little bit, and it'll kind of suck up into the cloth, the microfiber cloth that I use to really kind of smooth out the top. So that's how I like to dry it out before if it's too wet, and then I like to get it even drier right before I flow it the first time by rubbing it with a cloth. So in this case, you can see it's uneven. So the best thing to do is going to be going over it one more time, refilling the gaps that are left between the gap that's left between the ones that didn't have the top taken off. There's going to be that little gap between the stencil between the ball and the stencil, where you'll have a little bit of solder paste that can fill in there. That'll bring it to the same height as those that had the tops of them shaved off. So this is totally salvageable. It's not a big deal. And the one that he saw that had little to no solder in it or would look kind of funky, you'll be able to fill that with solder paste, and it should totally be fine. So let's keep watching, see what he does.
So take a closer look. See how some balls are flat on the top, some are not. That means we have uneven solder balls, and that's throughout the whole thing. So what we do is after we do that shaving process, we come in and add another layer right on top. We don't do anything else, just add another layer. This will pack in any of the empty voids, and then any of the pads that have a good amount of solder, that have a large ball there, it won't take any paste. So essentially, this only fills in what is needed, and then we come in with the clean cloth again, wrapped around our finger, and just try to wipe it off clean. Now we just have, you should be able to see how there's paste filled in the void. And then we repeat. See, if I go too fast, I can see some of the paste up here in the top is like overflowing already, trying to go into a different pad. You don't want that. So we just heat in big circles, preheat the whole area. Also, in this process of you preheating, it's heating the chip, which is also heating the cloth, and it's causing it to kind of sink down and create a kind of like a mold or a jig. Yeah, it's more like a mold, I guess, right? And then I move in closer. I'm also gently sliding my tweezers so I keep that pressure downwards. Essentially, to slide your tweezers, you let go a little bit of pressure, and then you kind of, slide back, and then you'll notice that nothing will move out of the way. Although if you do it,
you got to be careful about sliding the tweezers at all. If you slide it while everything's like molten, it could drag the stencil a little bit to that side you're dragging to, causing the solder to kind of lift off the pads, and you'll create a whole mess, and you'll have to end up reballing it. But if you have the right technique, if you find the right technique for you, you won't have that issue.
If you're like this and you're going down, if you're pushing down too hard, you're going to move the stencil with you, and you're going to mess up the reball.
Exactly.
So that does take practice. But usually after the second layer of this reball, it should be really even. All right, so this is the CPU here. Let's get a close-up shot. Take a look at
looks good.
How
it's
it
really
looks. Good. To me, all the solder balls are present and they look even. And in between the solder balls, there's no paste. So that's another big issue people run into when they're trying to reball. They'll get paste in there, and that's also from
two things. So if you have the solder paste too runny, that's when I've seen that I've gotten the issue with paste being in between the balls. The other thing, if you look really carefully at all of these solder balls, some of them actually look bigger than the other, or the ones next to them. Like there's a row, like for example, this one right here, this whole row, or these two rows almost look bigger than these three rows. And this section here might look smaller than this section. And you can tell if you look very carefully, there's flux that kind of goes all through here. And then there's flux that goes through these row right here. The flux creates kind of an optical illusion where it ramps up around the solder ball and makes it look larger than it really is. You can see that the ones that appear smaller have no flux around them. and they just look smaller. They're all in this case, they look bigger or smaller. They're actually probably all really close to the same size. And when you put the and you'll want to add additional flux to this to protect the exterior of the solder as you apply heat to it. I'm sure I'll talk a little bit more about that here in a little bit, but these all look really close. Some of them probably are a little smaller. Like this one's probably smaller than this one, but it's really, really close. Close enough that I wouldn't be too concerned about the size difference.
From the solder paste being too wet, you can actually see a little bit in there. So what I do is before I add any flux back on here, I just reheat it as is in midair. So I'm holding it with my tweezers in midair, and then I just kind of same technique, heat slow.
Doing it in midair will allow the heat to transfer really quickly through the entire chip, getting all of the solder to melt basically at the same time. If you have it on a surface, the surface is going to suck away the heat and it's going to take you longer to reflow it. So holding it away from any surface is going to make it reflow real quick and even.
Another funny thing is, depending on how much flux was in your paste, some balls might look a little smaller than others. That's because some are coated with flux. So in the light, it makes it look larger than it is, whereas the solder balls that are dry will look smaller. So like the liquid in the flux creates like a reflection that creates a bigger look to it. So right now I've reflowed. You can see all the solder balls are shiny. So that means it's liquid.
You can see it instantly when you set it down.
Now that I reflowed it dry,
you see when you set it down, it instantly, all of the solder balls started to solidify. You can see that they were kind of like shimmering almost as they solidified really fast because that surface sucked away the heat. Now it looks like he's going to add some flux. This will really show you what I was talking about, where they'll all look very even when he adds the proper amount of flux. And it's really important you get the right amount of flux on the CPU and not too much or even too little. So let's get in. Let's see where he goes from here.
Well, not dry, but with whatever was there behind, with just the residue, I'm not going to come in with fresh flux and coat the whole chip. You want to get flux on everything, but you don't want to overflow it. So I got a good amount, and then whatever doesn't have flux, you just kind of heat it, and you'll see it kind of will spread out and make contact with everything. What you want is the flux to make contact with every solder ball so that it reflows within the flux and creates a really nice looking solder ball. Look at that.
So as you can tell, he has applied what I would say the proper amount of flux. If you have kind of a puddle that's puddling up on one side, then you have too much flux. If there is an area where it hasn't spread to, then you have too little flux. If you have too much flux, dabbing the end of a microfiber cloth into it will suck it up as it's liquid, when the flux is in this very liquidous state, it'll suck up really easy into a cloth. And of course, applying more is really simple. And you want to also coat the surface of the motherboard that you'll be soldering to in flux. You want a very, very thin coat if you've added this much flux to the chip itself, because you don't want too much. Otherwise, what you'll get is basically it's the equivalent of a boat in a shallow pond, where the boat might touch some of the gravel as you go across it. It's like, but it will never actually make contact because it's just floating. It's suspended in the flux. You need to have enough flux to protect the solder joints and the solder from oxidizing, therefore not making a good contact. But you don't want to have too much flux, otherwise you're going to create a floating effect where it never actually solidifies and sucks down to the board.
And then as you give it time, you'll see the solder balls will solidify.
So you can see now, if you look in these areas, they all look the exact same size. What used to look small now looks the exact same size as the one next to it. So
and there you go. That's how you reball an iPhone 15 Pro CPU. Now this should translate to any other CPU. And this is just one of the many steps of CPU swap data recovery. So let's jump to installing this to the board. Now here's the NAND chip. This is the hard drive or storage chip. Here's what it looks like. And then here's the donor board. This is the one that's prepped for the CPU swap. So this is where the NAND goes. This is the EEPROM chip. This is also required to be transplanted, so don't damage it or lose it.
You can see he left it on. I always leave it on till the last second because these are so small that they're easy to lose. And so I always like to really hyper focus on when I'm messing with it, because if you lose this, all of the other work that you've done is void. There is no coming back from losing the EEPROM. The EEPROM is the key to everything communicating. It's the bridge between the two. If you don't have it, you won't get communication. If you don't get communication, there's no data. The EEPROM is vital to this entire repair. So I leave it on till the last second when I've already done the CPU, when I've already done the NAND, everything's ready to go. Then I'll pull and I'll swap them. And that way I don't risk losing it in the process.
And then on this side is the CPU. This has also been prepped, ready to go. I did had to clean up a little bit of the mess here. So there's some UV mask, but all the solder pads are present and there. And then this is the rest of the board. So this board is clean and not water damaged. I did pull those chips trying to repair a different board, and I was unable to, but those are not required for data. So I left them off. So let's go ahead and install the CPU. All right, so first let's install the NAND and flux. The chip goes this way, the dot on the bottom left. I'm going to use the same 330 heat because the paste we use to reball is lower temp. So because the paste is lower temp, it makes installing the chip way easier than factory solder. So the solder melts faster and makes the installation easier and less risky. Less heat is always better. All right, chips are flowed. Bump it, good. So I have a special fan here to cool boards down because I want this to cool down before I work on the CPU, because I want to be able to grab the board and flip it over. So you'll notice the same pattern of these cutouts. All right, some flux. Here's the CPU. Match the cutouts to where you're going to install it. So that would go this way. There you go. And same thing as reball. First, the whole board. You want to bring the whole board up to temperature. Now I'm kind of focusing just on the CPU. All right.
So you'll notice that he put very little flux on the board. And when it drops, you'll have flux that kind of squishes out the sides. And that's what I look for, is I look for, as soon as sometimes it's hard to tell when the chip is dropped because you're looking straight down on top of it. And one easy indicator that it's dropped is that you'll see flux kind of just spill out the edges. And that way, you know, okay, it's time to start nudging on it to get it to agitate enough that any joints that haven't yet attached to themselves, what happens is when you push it to the side, everything kind of, all of the solder that's there kind of stretches, and in that stretching it almost dips down a little too. It kind of goes over and down, causing the solder that hasn't yet connected to make even more contact with the pad below. And then when it snaps back in place, all of that movement really guarantees that all of the solder joints are there and are making good contact. It's just kind of one of those techniques that you'll find yourself, as you get through and you practice these things, perfecting. So let's finish up this video and see if it works.
Close. All right, so I'm going to try to bump this gently. See that? So that tells me that the CPU has melted and soldered on. I'm going to hit it again with the fan. Now let's take a look at the installation. I can see some solder balls here, right here. Although the rest are kind of hard to see. So this should be good. Let's go ahead and test. All right, so I have the power supply connected to this boot box at 4.2 volts and 3 amps short to power button pin. All right, there it goes. And look at that. We have a Apple logo. Now keep in mind, this is a 15 Pro Max screen, but it does work on 15 Pro because they're the exact same motherboard. So it'll be a little distorted, but it works. So it makes it really nice for me because I don't have to buy a separate screen just for 15 Pro.
You could kind of see as you look at this how the phone wants to start displaying the image right here. Everything else is kind of dragged down. So yeah, the 15 Pro Max screen works on the 15 Pro. Same motherboard. It's just kind of funky to see the edge of the display. It's almost like the lines on this display don't, they're caused because the screen wants to only start right here on the edge and here at the bottom. So it's kind of unique.
And look at that, we have the lock screen, we have touch, and it's working. All right, so there you have it. The CPU has been reballed on this iPhone 15 Pro successfully. The phone boots up. Now we're really close to getting data. There's a few more steps I gotta do, but this was the most difficult and riskiest part, which was successful. So let me know down below in the comments what you guys learned about CPU reballing, what critiques you have about my technique. Do you have something you don't like about it? Let me know what you guys think. I like to hear from you guys. I typically try to respond to every comment on there. Also, I will link to all the tools from today's video, my boot box, microscope, hot air station, stencils, the paste, all that stuff. I'll link it down below. I spent a lot of time getting all those links for you guys, but if I leave anything out, let me know. Also, get yourself one of these t-shirts if you want to support the channel. I have a lot of repair related designs on there. Also, join my VIP community, which is called my locals community. I have that link down below. So if you guys want to see a full, from beginning to end CPU swap video, I will post that down below. Thanks everyone for watching. I'll see you guys in the next one.
All right, so let me know what your thoughts are in the comments below. And if you have a video that you've watched or you come across that you think should be featured on the channel, comment it in a video with the link. I look forward to finding and sharing videos with you guys throughout the year that I find to be worth the watch, along with all of the other repair videos that we're going to be going through together. This video is already long enough, so thanks a ton for watching. We'll see you in the next video.